A very good day to Madam from me and Priscilla. Today we are going to present our topic arithmetic and geometric sequences. So, what is arithmetic sequence? Arithmetic sequence is the sequence where the common difference remains constant between any two successive terms. Let us recall what is a sequence. A sequence is a collection of number that follows a pattern. So for example, you can see 11, 15, 19, 23, and 27, which is an arithmetic sequence because there is a pattern where each number is obtained by adding 5 to the previous terms. So we have two formulas for the arithmetic sequence. Next. So before that, let's dive more into arithmetic sequence. So again, arithmetic sequence can be defined in two ways. A sequence where the differences between every two successive terms are the same, or every term is obtained by adding a fixed number, positive or negative or zero, to its previous term. So let's go back to an example. Consider the sequence 2, 7, 12, 17, and 22 is an arithmetic sequence because every term is obtained by adding a constant number 5 to its previous term. So how do we find that? So you can see that the first term, which is called A, equals to 2. And to find the common difference, which is the constant number, all you have to do is take the second term minus the first term, which is 7 minus 2 equals to 5. Next. So now let's dive into some arithmetic sequence formula. So obviously now you have seen that you have discovered the first term, which is A, and the common difference, which is D. But there are other formulas that we have, which is to calculate the n term and the sum of an n term, and also back to the first formula, the common difference. So the n term formula is an, which is the term, equals to a, which is the first term, plus n, the term that we're trying to find, minus 1, and then the common difference. So for the sum of the terms, we have n divided by 2, which is the term we're trying to find divided by 2, to a is obviously the first term, plus n, the term we're trying to find, minus 1, and the common difference back again. So just to remind you, to find the common difference, we just have to take the second term minusing the first term. So as you can see, all the letters remain the same in the formula. Next. So now let's get into the application of arithmetic sequences. So for example, find the 25th term of the given arithmetic sequence 3, 9, 15, 21, and 27. So we already know what formula we're going to use because now we're going to find the term. So firstly, what we have to do is list down everything. So for the first term, we have A equals to 3. To find the common difference, all we have to do is take the second term minus the first term, which is 9 minus 3 equals to 6. And then the n term where we are supposed to find is the 25th term. So now all we have to do is insert that into the formula, which is an equals to a plus n minus 1d. So the term we're trying to find is 25th. So now we just have to do is 3 plus 25 minus 1 times 6. And the answer is 147. So the 25th term given for the arithmetic sequence is 147. Next. So let's look into another question. Miss Natalie earns $200,000 per annum and her salary increases by $25,000 per annum. Then how much does she earn at the end of the first 5 years? So let's not get confused yet and let's list down everything. So the amount earned by Miss Natalie for the first year is $2,000. So the increment, which is the difference, is 25,000. So now we have to calculate her earnings in the first 5 years. Hence, n equals to 5. So now we have all the information. Now let's just insert it into the sum of terms. which is n divided by 2, bracket 2a plus n minus 1d. So now let's insert everything in. So 5 divided by 2, 2 times 200,000 plus 5 minus 1 times 25,000. So now we get the answer is 125 million, which is 12,550,000. So she earns 12,050,000 in 5 years. That's it. Now I'm going to pass to Priscilla to explain about geometric sequences.
Now I will be presenting on the geometric sequences. So, geometric sequences is whereby a type of sequence where the ratio of every two successive terms is constant. So, like just now, we call it as common difference, but in geometric sequence, we call it as common ratio, whereby every term of the common ratio is multiplied by a constant which result in its next term. So, a geometric sequence has A, AR, AR2, where the A stands for the first term and R stands for the common ratio of the sequence. So the common ratio can also be positive or can be negative. So I'll proceed with the formulas of geometric sequence. So we have the formula whereby we can actually state the formula as AR. When we see the sequence, we can state it on top the number. We can label it as AR, AR2, AR3. So the A is obviously it's the first term. So AR, the first one, is for the first, after that, the next term, AR, and then AR2, AR3. So for the n term, we use the formula as an equals to arn minus n. Or we have the other one, which is an equals to an minus 1. So sum of the first term, we have the formula whereby Sn, the number of term, equals to the first term times with the common ratio with the number of term minus with 1 over common ratio minus with 1. So for the application of geometric sequences, so for the example, we can see the question was asking about find the seventh term of the sequence given, which is 1, 6, 36, 216, and 1296. So for the solution is, we need to identify first which is the first term. So the first term is A equals to 1 because that is the first one. And then how to identify the common ratio? See, the common ratio is very simple, whereby taking the AR minus with the, AR divide with A, which is 6 divide with 1. We will get 6. Or even to clarify more, we can take AR2 divide with AR, which is 36 divide with 6. We get 6. To confirm furthermore, we can also take 216 divide with 36, we get 6. So we can see that it is a constant of common ratio. So for the nth term, the geometric sequence, we calculate using the formula of an equals to the first term times with common ratio power of number of term minus with n. So we need to substitute a number of term because they have given in the question, which is seventh term, like we can see here. So when we are substituting, we are using 7. So A7 equals to 1, which is our first term, multiply by 6, our common ratio, to the power of 7, again the number of term minus with 1, where all these equals to 46,656. That is the seventh term of given geometric sequence. So for the second example, we have to find the sum of the first 8 terms of the geometric sequence, which is for 2, 6, 18, and 54. So the solution whereby we still need to do the number of term solution, then only we can do it, the sum of some geometric sequence. So firstly, we can see the first term is A equals to 2, which is the first number. Then the common ratio, as how I said just now, AR divide with A, or we can use AR2 divide with AR or AR3 divide with AR2. So For example, we can see here when we divide 6 divide 2 equals to 3, 18 divide 6 equals to 3, 54 divide 18 equals to 3. So all is same. We can see the constant common ratio, the multiplication is only 3. So the number of terms we need to find is we will be calculating is 8. So the sum of this geometric sequence is we will be using the same formula I have told previously during the formula just now. So we know the number of term is 8. So our first term 2 times with 3, which is our common ratio, power of our term number, which is 8, minus with 1, over 3 minus with 1, which is the common ratio minus with 1. So we get a total of 6,560. So the sum of the first 8 terms of the given geometric sequence is 6,560. That's all from us. Thank you.